Hello guys, welcome back to my channel Science to Scientist. Today we are going to start a new chapter, that is structures of atom. So let's start this. Atoms are the basic building blocks of matter as we have studied in our previous chapter. Different kinds of matter exist because there are different kinds of atoms present in them. Now, charged particles in matter. Whenever we rub two objects together, they become electrically charged. This is because atom contains charged particles in them. Therefore, atom can be divided further into particles, that is protons, electrons and neutrons. So here we can see that electron location is outside the nucleus. The charge is minus 1.602 into 10 to the power minus 19 coulomb and the unit charge is minus 1. Sorry, it's minus 1. And the mass is AMU, that is 0.00055. The mass in gram is 0.00091 into 10 to the power minus 24. The second is proton, having location in nucleus. Its charge is 1.602 into 10 to the power minus 19 coulomb. The unit charge is plus 1. It's plus 1. And the mass in AMU is 1.00727. The mass in gram is 1.67262 into 10 to the power minus 24. Whereas neutron, the location is in nucleus, the charge is 0 and unit charge is also 0. The mass in AMU, that is astronomical unit, is 1.00866 and the mass in gram is 1.67493 into 10 to the power minus 24. Now, what is the charge which I have said you coulomb? So what is this? So let's elaborate what is a coulomb. The coulomb, which is denoted by the symbol C, is the international system of units, that is SI unit of electric charge. It is the charge with symbol capital Q or small q, transported by a constant current of 1 ampere in 1 second. We will study about coulomb in our physics classes later on. By this, we have concluded from the table that atom consists of protons and electrons in a balanced proportion. Protons exist in the interior of the atom and electrons exist in the exterior of the atom. Therefore, electrons can be removed from an atom. Now, Dalton's atomic theory. The postulates of the atomic theory by John Dalton were: first, the matter is made up of tiny particles called atoms that cannot be divided. Second, atoms are never formed or destroyed during a chemical reaction. Third, atoms of an element exhibit same nature, that they have the same size, mass and character. Fourth, atoms of different elements exhibit variant nature. They do not have same characteristics. Fifth, atoms form compounds by combining in a ratio of whole numbers. And last, the compound contains a constant number and the kinds of atom. By this, Dalton suggested that atoms can neither be created nor destroyed and are indivisible. But the discovery of electrons and protons in atoms led to failure of this aspect of Dalton's theory. Now, the structures of atom. We have learned in Dalton's atomic theory in chapter 3rd, which suggested that the atom was indivisible and indestructible. But the discovery of fundamental particles, that is electrons, protons, inside the atom led to the failure of this aspect of Dalton's atomic theory. Now, Thompson's model of an atom. According to J.J. Thompson, the structure of an atom can be compared to Christmas pudding, or in common day life we can say the Britannia cake pudding, where electrons are present inside a positive sphere. This is the spherical cloud of a positive charge, which we can say it is a bread, whereas the electron can be called the chocolate chips present in a plum pudding. An atom is composed of a positively charged sphere in which electrons are embedded, and atom is neutral as the positive and negative charge are equal in proportion. Now, Rutherford's model of an atom. Rutherford experimented that the thin gold foil by passing alpha rays through it. He expected that the gold atoms will deflect the alpha particles. Now let us see observations and inferences of Rutherford model of an atom. And the observation was the alpha particle which had high speed moved straight line through the gold foil. The inference of this experiment was the atom contains a lot of empty space. The second observation was that some particles got diverted by slight angles, making the inference positive charge in atoms are not occupying much of its space. The third observation was that only 1 out of 12,000 particles bounded back, making the inference that the positive charge are concentrated over a particular area of atom. Thus, Rutherford gave the nuclear model of an atom based on his experiment, which suggests that first, atom contains a lot of unoccupied space. Second, there is heavily positively charged substance present in the center of the atom, which is called the nucleus. And the third one, the nucleus contains an equal amount of positive and negative charges. Now let us talk about the drawbacks of Rutherford model of an atom. The orbital revolution of the electron is not expected to be stable. Any particle in a circular orbit would undergo acceleration. During acceleration, charged particles would radiate energy. Thus, the revolving electron would lose energy and partially fall into the nucleus. If this were so, then the atom should be highly unstable and hence matter would not exist in the form that we know. We know the atoms are quite stable. Now let us talk about the nucleus of an atom. The nucleus ID located at the center of the atom. All the mass of the atom is because of the nucleus. The electrons revolve around the nucleus in circular paths which are called orbits. If we compare the size of atom and nucleus, the nucleus is much smaller than atom. Now let's talk the drawbacks of nuclear model of an atom. The nuclear model of an atom failed to explain how an atom remains stable despite having positive and negative charges present in it. Maxwell has suggested a theory according to which if any charged particle moves in circular motion, it radiates energy. So if electrons start moving in circular motion around the nucleus, they would also radiate some energy which would decrease at the speed of the electrons. As a result, they would fall into the nucleus because of its high positive charge. Now, I want to ask a question. What are nucleons? The answer of it is that protons and neutrons are collectively called nucleons. Moving further to Bohr's model of an atom, Bohr suggested that electrons spin around the nucleus in an individual separate path or unattached orbit. The electrons do not emit any energy while moving in Dyson special orbit. Third was that these orbits are also called as energy levels. And the last one was that they are represented using the letters of numbers as shown, that is K shell, L shell, M shell or N shell, where K shell has the N value as 1, L shell having N value as 2, M shell 3, N shell 4 and so on. And in the center we have our nucleus. Now talking about the neutrons. James Chadwick discovered that there is another subatomic particle present in the atom. This particle carries no charge and is known as neutron. Please focus, it's called neutron. Therefore, we can conclude that atom consists of three types of particles, that is electron, protons and neutrons, where electron carries a negative charge, protons carry positive charge and neutrons, they are neutral, completely neutral, means having no charge on it. Now the distribution of electrons in different shells or orbit. If orbit number is, let us consider the orbit number as n, so then the numbers of electrons present in the orbit will be 2n squared. So for n as 1, the maximum electron present in the K shell as n value of 1 is in K shell. So that will make 2 into 1 raised to the power 2, which makes 2 into 1 equals 2. Now the outermost shell can contain at most 8 electrons. The shell in an atom are filled in sequence. Thus, until the inner shells of an atom are filled completely, the outer shell cannot contain any electron. Moving further to valencies, valence electrons. Electrons exist in the outermost orbit of an atom are called valence electrons. The atoms which have completely filled the outermost shell are not very active chemically. The valency of an atom or the combining capacity of an atom is given by the numbers of elements present in the outermost shell. For example, helium contains 2 electrons in the outermost shell, which forms a chemical bond with another element. Now, what happens when the outermost shell contains a number of electrons that are close to its maximum capacity? Valency in such cases is generated by subtracting the number of electrons present in outermost orbit from the octet, that is 8. For example, the oxygen contains 6 electrons in its outermost shell. Its valency is calculated as 8 minus 6 equals 2. This means oxygen needs 2 electrons to form a bond with another element. Atomic number of an element. Atomic number is the number of protons in an atom and it is represented as Z, whereas the mass number of an element is the sum of numbers of protons and the numbers of neutrons. For example, in nitrogen, it has 14 as mass number, 7 as atoms number. Now talking about isotopes, the atoms of an element can either exist in several forms having similar atomic numbers but varying mass numbers. They are pure substances. Isotopes have similar chemical nature and have distinct physical characteristics. Talking about isotopes of hydrogen, hydrogens are of 3 types, that is hydrogen, deuterium and tritium, where hydrogen has mass number of 1, deuterium having 2 and tritium having 3. Now let me ask a question. Where can we use isotopes? So the answer of this can be, the isotopes can be used in the fuel of nuclear reactors, treatment of cancer or treatment of goiter. In the fuel of nuclear reactor, isotope of uranium is used, where uranium is denoted as UR. Treatment of cancer, isotope of cobalt is used, and for the treatment of goiter, isotope of iodine is used. Now let us consider an example. Consider 2 atomic species, namely U and V. So are they isotopes? So the answer would be like the U and V have protons 5 and 5 equals, neutrons have 5 and 6, making the mass number 5 plus 5 equals 10 and 5 plus 6 equals 11. But we need to get the atomic number. So both of them have atomic number as 5. From the above example, we can infer that U and V are isotopes because their atomic number is same. Now talking about isobars, the atom of several elements can have a similar mass number but distinct atomic masses. Such elements are called isobars. Now let us see about isobars. Isobars, we will see atomic number, their mass number, the electron present in the atom, the protons and the neutrons. So for the argon, it has atomic number 18, mass number as 40, electrons 18, protons 18, making the neutrons 22, as 40 minus 18 is equal 22. Now for the isobar of potassium, it's 1940, making atomic number 19, mass number 40, electrons 19, protons present in it, it's 19, making the neutrons 21. That is 40 minus 19 making 21. The next one is the calcium, where it is having atomic number as 20, mass number 40, electrons present in it as 20, protons present in it as 20 and the neutrons totals as 20, as 40 minus 20 equals 20. Let's practice some question and answer to make control on this chapter. Question and answers from page number 47. So first question is, what are canal rays? Answer is, E. Goldstein discovered positively charged rays. 2 rays are called canal rays. These rays travels in a direction opposite to cathode ray canal rays. Led to discovery of positively charged subatomic particles known as protons. Means of this question is that E. Goldstein discovered 2 phases which are called canal rays, in the direction opposite to flowing in cathode rays. As cathode rays, if suppose are flowing in this direction, so the two rays will be moving in another direction, that is opposite to that direction, making or the discovery of the positively charged subatomic particle, which is we call proton. Now the second question is, if an atom contains 1 electrons and 1 protons, will it carry any charge or not? So answer is, the atom will not contain any charge, because 1 negative charge of single electron and 1 positive charge of single proton are neutralized by each other. According to this question, it is that if one positive charge is present and one negative charge is present, the sum up of will make 0, as +1 and minus 1 makes rise to 0. So we get the numbers of electrons and protons present on the positive charge will be neutralized by each other. Now question is from page number 49. On the basis of Thompson model of an atom, explain how the atom is neutral as whole. According to this question, this is asking that how an atom can be neutralized as whole. So the answer will be, as per Thompson model of an atom, the numbers of electrons are equal to the numbers of protons. As we have studied or viewed in the lecture, that the numbers of electrons and the numbers of protons are always equal in an atom. Hence, the positive charge and negative charge are neutralized by each other. That makes atoms neutral as whole. In the previous question only, I have told that +1 plus -1 give rise to equal, making neutralization of anything. So similarly, in an atom, a positive charge and a negative charge is being neutralized as a whole. Now second question is that, on the basis of Rutherford's model of an atom, which subatomic particle is present in the nucleus of an atom? So the answer would be, the subatomic particle proton is present in nucleus of an atom according to Rutherford's model of an atom. So the main thing is that nucleus of an atom according to Rutherford's model of an atom. Let's now practice our fourth question. What do you think would be the observation of if the alpha particle scattering experiment is carried out using a foil of metal other than a gold? That is not foil, that's a foil, F-O-I-L, foil. So the answer is that the observation would have been same even if alpha particle scattering experiment is carried out using a foil of metal other than a gold, as the alpha particles can move even through a metal. Because any metal having a thin sheet making a single layer of an atom, so if we take a gold or any other metal, then also the alpha rays will be passing through it. Now the fifth question is, name the 3 subatomic particles of an atom. So as we have studied that the subatomic particles of an atom is proton, neutron and electron. Now the sixth question is, helium atom has an atomic mass of 4U and 2 protons in its nucleus. So how many neutrons does it have? So the answer is very simple, that the numbers of neutrons present in helium atom is the atomic mass minus numbers of protons. So that will make 4 minus 2 equals 2. Now the questions from page number 50. Write the distribution of electrons in carbon and sodium atoms. So the answer would be, the distribution of electrons in carbon atom, that is atomic number of the carbon, is 6, making it 2, 4. Now the distribution of electrons in sodium atom, that is atomic number of sodium, is 11, making it 2, 8, 1. Okay. Now the second question is, if K and L shells of an atom are full, then what would be the total numbers of electrons in the atom? So our answer is quite simple, and it is that if K and L shell, its K and L shells of an atom are full, then the total numbers of electrons in the atom will be 10:0. Okay, because K shell can accommodate total to an L shell, here it's L, can accommodate maximum 8 electrons, that makes a total of 10. as in K shell 2 electrons will be present, and in L shell 8 electrons, making it the sum of 10. Okay. Now the question from page number 52. How will you find the valency of chlorine, sulfur and magnesium? So the electron present in the outermost shell of an atom are known as the valence electron. Those electrons determine the valency of the atom. So the atomic number of chlorine is 17, making it 2, 8, 7. And shown the number of valence electrons of chlorine is 7, and it needs one more electron to complete its octet. Therefore, its valency is 1. Now, similarly for sulfur, it's 16 and making it 2, 8, 6. Shown the valence electrons for sulfur is 6 and it needs 2 more electrons. It's 2, T-W-O, 2. 2 more electrons to complete its octet. Therefore, its valency is 2. Valency is 2. For magnesium, it is having 12, making it 2, 8, 2. So it becomes easier for magnesium to give its 2 valence electrons, give away its 2 valence electrons, then to acquire 6 more. Therefore, its valency is 2. But this valency is in opposite, as it is losing the electrons. And the last from the questions from page number 53. Write the electronic configuration of any one pair of isotopes and isobar. So the isotopes of carbon is C612 and C613. Electronic configuration is 2, 4 because both the atoms have the same atomic number, that is 6. Okay, and the same numbers of electron as 6. Now the isobars of calcium, that is 2040, is 2, 8, 8, 2. As atomic number is 20. For calcium of 1840 is 2, 8, 8, making the atomic number as 18. So by this we have completed the in-text questions of this chapter. So please do exercise questions which are present at the end of this chapter.